Today's class, I just realized that I ran out of marker, so unfortunately I will not be able to write on the board today. So our class is going to be solely on a paper. Thanks for those who are just joining. Please type your name and the lecture you attend, and also do where to like the video. Type your name, type the lecture you attend, do where to like the video. Type your name, type the lecture you attend, and do where to like the videos. I have about 5 persons online, but nobody is doing where to like this video. Just 3 likes from 5 persons online. Your name, the lecture you attend. I'm actually going to be teaching today because I can't solve past questions due to the unavailability of my markers to write on the board today. Promise from Starbrains Wasota, you're welcome. Precious from Cambridge, you're also welcome. You're waiting on other people. If you're just joining us, please click the like button and also do where to type your name and the lecture you attend. We're going to continue from where we stopped on the WhatsApp class on radioactivity today. Audrey from Solid, you're welcome. Thanks for the like. Hold on, please. I'll be back. Just give me a while. Otasue from Cambridge, you're welcome. Please, as you're joining, do where to like the video and also ensure you click on the Success from Solid, you're welcome. Like I said, we're going to be teaching today, no past question today because my markers are unavailable at the moment. So we're going to be learning from a notepad today. Wilson from Solid, you're welcome. Please, if you know you're just joining us and you've not clicked the like button, please do that now. We started a class on radioactivity and we are going to continue that class today. It's a class you don't want to miss. Please do well to share this video to your friends. I want us to share this video to our friends right now. Share it on your various group. Share it on your various WhatsApp group. Just click that 3 dots, go to where they have share, forward it to your various WhatsApp group, tell them Photon is online, and tell them to join the channel. In the next 2 minutes or so, we'll be starting up the class. Sylvia from Solid, you're also welcome. Sylvia from Solid. Examination is approaching. There is no time again. Sylvia from Solid, you're welcome. Adekunle from Solid. Adekunle, you're also welcome. Please, if you're just joining us, please tap on the like button. If you're just joining us, type on the like button. Eugene from Cambridge, you're welcome. Miracle from Solid, you're also welcome. Please, for those of you just joining us, tap the like button, click on the like button, share these videos to your different WhatsApp group in your lectures and tell them to join us, for we are about to kickstart. We started the topic called radioactivity, and we are going to continue that topic today. All right? So tell every one of them to join us now. I did teach radioactivity in the WhatsApp group. I did. Maybe you're not around for that class. I started with structure of an atom, and I gave a definition for radioactive decay. And I told you when next to meet, we're going to continue from there. Please, if you're in that class where I started radioactivity from structure of the atom, please type something here. Well, we didn't really do much, so you have nothing to be scared of. We didn't do much. I only introduced structure of the atom, which you did in chemistry. It's today we're going to be doing the main work. All right, once it's 10 minutes, which is 1 minute away from now, we'll start up. If you're just joining us, please hit the like button. And if you're ready with us, the topic is types of decay. Do well to write that down. Types of decay. Please do well to share this video. Just give me a minute. All right, so by my time now is exactly 10 minutes, and I think we are ready to go. We can no longer wait for any other person. Please, if you're part of this group and you've not clicked the like button, please do that now. All right, so we start. Types of decay. Okay, I'm going to be detecting some of the things we're going to be doing today. All right, so there are three basic types of decay. There are three basic types of decay. Namely, the first one is called alpha decay. Alpha decay, that's the first one. The second one is called beta decay. Beta decay. and the third one is called gamma decay. Gamma decay. So those are the three types of decay we have. We have alpha, we have beta, and we have gamma. So you have them listed on the notepad there. You have your alpha decay, you have your beta decay, and also you have your gamma decay. So those are the three decays we have. Do where to put them down on your notepad. Your alpha, your... Have you gotten that? Can I proceed? Can I proceed? If I can proceed, please just type yes so I can move on. All right. So since you said I can now proceed, I will. All right. Now, place an asterisk. We start with alpha decay. Alpha decay. Alpha decay. We start with alpha decay. Now, under alpha decay, right? When a radioactive element emits alpha particles, when a radioactive element emits alpha particles, when a radioactive element emits alpha particles, it is said to undergo alpha decay. When a radioactive element emits alpha particle, it is said to undergo alpha decay. Full stop. All right. An alpha particle is represented as an alpha particle is represented as 4,2He. An alpha particle is represented as 4,2He. And that's the symbol of helium nucleus. All right. We call this helium nucleus. So if you are asked on the day of your examination, which of these represents an alpha particle, the answer to that question is helium nucleus. Take notes. Now, you can see that helium here has a mass number of 4 and an atomic number of 2. In the previous class, I told you that the mass number is also known as the nucleon number, while the atomic number is also known as the proton number, all right? And mass number and atomic number are related by a formula I gave to you in our previous class. But that's not what we are looking at today. Now, write this very fast. In an alpha decay, the mass number of the radioactive element in an alpha decay, the mass number of the radioactive element decreases by 4. The mass number of the radioactive element decreases by 4. So that is to tell you that whenever there is an alpha decay or disintegration, the mass number would always decrease by 4. So let's continue. Why the atomic number decreases by 2? Why the atomic number decreases by 2? All right. So the mass number decreases by 4. Why the atomic number decreases by 2? So they ask you what type of decay is observed when the mass number is decreasing by 4 and the atomic number is decreasing by 2. The answer to that question will become the alpha decay. So with that, we can proceed. Now, right. Such decay, continuation. Such decay is represented as now let's assume, let's use what do we use? Let's use R as a radioactive substance. Okay, now the atomic number is 4. The mass number is 4, while the atomic number is 2. If this particular atom is going to undergo disintegration, what you'll be getting is, we use an arrow to symbolize a disintegration. All right, an arrow is used to symbolize a disintegration or a decay. Okay, so what is going to happen here is that the mass number is going to decrease by 4 and the atomic number is going to decrease by 2. Okay, let's use this rather, please. Sorry, apology about this. Let's use this. R with letter A and letter Z. Okay, the A there stands for the mass number, while the Z there stands for the atomic number. Now, if this is going to undergo disintegration, the first thing we are going to do is to attach an arrow. All right. After attaching an arrow, the next thing we are going to do is that it's going to produce another element. We can use S. Now, the word decrease means minus. Okay. So the top will now become A minus 4. A minus 4. While the bottom will become Z minus 2. Okay. The top will become A minus 4. The bottom will become Z minus 2 plus the alpha particle itself that has an atomic mass of 4 and an atomic number of 2. We can call this He, like I told you, helium nucleus. Whenever there's a disintegration and 4 is the mass number, 2 is the what? Atomic number. The element that is produced in the process is called helium. Now, there is no disintegration that does not occur without the release of energy. So the last thing we are going to be attaching to this formula is energy. So this is actually the mathematical representation of the decay of an alpha particle. So let me zoom in. Shagun Victory, you're welcome. Please don't forget, if you are just joining us, type your name and the lecture you attend. And also do well to hit the like button. The likes are decreasing, please. If you are joining us and you've not done that, hit the like button and also learn to share the videos to others. Shekina Eremusele. This is an element R. A is called the mass number. Z is called the atomic number. If it is going to be releasing alpha particle, it simply means that the mass number will decrease by 4 and the atomic number will decrease by 2. That's why the new element that was formed here, S, has A minus 4 and Z minus 2. Now, whenever this occurs, alpha particle is going to accompany it. 4 and 2. That's the constant for alpha particle plus energy. Alon promise. I just explained it now. If you listened, you would have gotten it by now. Shagun Victory from Star Brains. Your name and where you attend. Your name and your lecture, not just the lecture. I've zoomed in. I presume you should be seeing it by now. All right. So that is that on alpha particle. Now, another thing I need you to know is that the arrow and the S have names. Okay. So write this very fast. Where R is called the parent nuclei. Where R is called, or rather, let me use the word parent element. Where R is called the parent element and S is called the daughter element. So you must be able to identify both parent and daughter element, okay? The element before the arrow sign is called the parent element, while the element after the arrow sign is called the daughter element. Now, can we go on to the next part? Can we go on to the next part? Can we go on to the next part? If we can, just type yes and we move on. Can we move on to the next part? I'm still waiting for your message. All right. Thank you, Amori. Success. Precious Edigba, I won't be able to recap, okay? I'm sorry about that. So let's move on. Now we have looked at alpha particle. The next thing we are going to be looking at, place an asterisk, is called your beta decay. Beta decay. Beta decay. Now, under beta decay, the beta sign is used to represent it. Under beta decay, the beta sign is used to represent it. Now, right. When a radioactive element emits beta particles, when a radioactive element emits beta particles, when a radioactive element emits beta particles, electrons are emitted in the process. Electrons are emitted in the process. Full stop. Electrons are emitted in the process. Now continue. The mass number of the parent element, the mass number of the parent element remains unchanged. The mass number of the parent element remains unchanged. The mass number of the parent element remains unchanged. Why the atomic number decreases by 1. The mass number remains unchanged. Why the atomic number decreases by 1. Parent element is the element that undergoes disintegration. Promise. The element that undergoes disintegration is called the parent element. All right. Now, right now, full stop. This is represented by this. The mass number is 0, while the atomic number is -1. The mass number is 0, while the atomic number is -1. So whenever you see this type of disintegration, it is called a beta decay. Electrons are emitted in the process, okay? Now let's proceed. This is generally represented below. This is generally represented below. All right, now I need you to help me correct something. Okay, I actually taught this because I noticed in most of the textbook we have, what I just defined for you is what you find there. But I noticed something when I represent my equation. Something actually happens in this way. So this is what you're going to do for me. Now go back to that place where I said the atomic number increases by 1. Cancel out that increases and write the word decreases. The atomic number doesn't the atomic number doesn't decrease by 1. The atomic number actually increases by 1. So cancel where I told you to write decreases and convert it to increases. Don't tell anybody this secret, all right? The part where I wrote decreases, cancel it out and write increases. So the atomic number of a beta decay actually increases by 1, even though it is represented by -1. The -1 shows that there is an increment, not a decrement. All right? Thank you. Now, this is the equation for a beta decay. Now, the same way we have an alpha decay, you have an element R. Now, when this arrow, it will always come with A and Z. Remember, the A here stands for the mass number, while the Z stands for the atomic number. All right? Now, this will undergo disintegration. I told you always place an arrow for disintegration. Now, when it undergoes disintegration, you're going to get a new element, S. And what happens is that the atomic number for a beta decay does not change. So you still have A. But what did I tell you about the mass number? It will increase by 1. So you'll be having Z plus 1. Z plus 1. All right? Then you know that you cannot forget the fact that the electron emitted will also come with it. That means 0 and -1 with your electron. 0 -1 with your electron. And the last thing I told you, there cannot be a decay without energy. So energy will always come with it. This is the equation for what? A beta decay. Please, if you are just joining us, type your name and the lecture you attend. And please do not forget to hit the like button. Hit the like button. Please do that now. Hit the like button. And also share these videos to your groups. If you are from Cambridge Tutorials, share this video to the Cambridge group. If you are from Solid, you do the same thing. If you are from Star Brains, if you are from Brainford, if you are from Success Point, wherever you are my student, do well to share this video to your individual group so that others can join and benefit what you're benefiting right now. We have just 17 likes, which is not really impressive enough. All right, so that's what happens whenever beta particle decides to undergo disintegration, okay? So let's move on to the next one. Let's move on to the next one. Gamma decay. Gamma decay. I told you there are 3 types of decay. You have your alpha decay, you have your beta decay, and you also have your gamma decay. Now the gamma decay is represented by the symbol, the gamma sign. All right? Gamma decay. So right, for a gamma decay, the radioactive element emits gamma rays. For a gamma decay, the radioactive element emits gamma rays. The radioactive element emits gamma rays, which are electromagnetic radiations. Which are electromagnetic radiations. Which are electromagnetic radiations. Full stop. Now right, both the mass number and the atomic number, both the mass number and the atomic number remains unchanged. Both the mass number and the atomic number remains unchanged. All right, so at this point, we are actually going to go into some past questions. Then after that, we are going to go into half-life proper. Then after that, we go into number of half-lives. Then after that, we look at half-life decay constants and the total time of decay. All right, before we now delve properly into other aspects that has to do with, your artificial nuclear transmutation and also the Einstein's mass energy relations, okay? Then we'll look at the electronic volt and also the binding energy. There's a lot of things to look at here. So let's write. Jamb. Now this question kept coming out over and over again. So let's look at this question. Jamb. So I'm going to write the question down. Then you can copy from what I wrote. All right. All right, there you have it. So quickly do where to write down this question. Do where to write down this question. Please, if you are just joining us, write down your name and the lecture you attend, and also do where to hit the like button, please. Sorry for the breakdown in network. We are back. Sorry, the question is there's something missing in the question, okay? The question doesn't end here. You add this, please. So add this to it. If two beta particles are also emitted in quick session, if two beta particles are also emitted in quick session, all right, so can I go ahead and solve this question? If you want me to solve this question, just type go ahead. If you want me to solve this question, just type go ahead. All right, thank you. So to solve this question, I will go ahead and solve this. We'll be needing a particular equation that will help us. Now, how do we write this equation? Very easy. Now, I'm going to read the question. A radium nuclide 22688 decays by emitting an alpha particle in quick succession to form radon. What is the correct representation of the radon formed if two beta particles are also emitted in quick succession? The first thing you're going to do is to write out the element radium. And that's Ra, if I'm not mistaken. The mass number was 226. While the atomic number was 88. Now, we're told that this particular element disintegrated. I told you disintegration, you always place an arrow there for disintegration. To give us two things. Now, the first thing it gave to us was radon. That's radon is written as RN. Now, we don't know the the mass number. We don't also know the atomic number. So we put it as A and Z. But we were told that there were alpha particle that was emitted in session. An alpha particle is represented with helium. All right? We were also told that there were two beta particles, meaning there were two, beta is represented as 0, -1, and electron. And don't forget, energy will always join it. So what are we simply looking for in this question? We are looking for the value of A. We are also looking for the value of Z. So as a smart person, this is what we are going to do. We are going to employ our knowledge of chemistry called the balancing of chemical reaction. All right. Now let's go to the mass number. On my left-hand side, the value of my mass number is 226. So I'm going to write 226. That's the value of my mass number. Will now be equal to, on my right-hand side, the first mass number I have here was A. So I'm going to write A plus, the second mass number I have here was 4. So I'm going to write 4 plus, you will notice that the mass number here is 0. But we're told that it was 2 beta that was emitted. So we are going to use these 2 to multiply this 0. So that becomes 2 times 0. All right. And as a mathematics student, we know 226 will definitely give us A plus 2 times 0 is 0. 4 plus 0 will still give us 4. So we are going to make A the subject of the formula. Therefore, taking 4 to the other side, and it will become minus. So that becomes 226 minus 4. And if you take away 4 from 226, you will get 222. So that is the atomic number of radon. Now, the next thing now is to get our Sorry, that's the mass number of radon. The next thing now is to get the atomic number. The same way we solve for the mass number is the same way we are going to solve for the atomic number. Now, how do we solve for the atomic number? On the left-hand side, the value of the atomic number is 88. So you write 88 equal to. On the right-hand side, we have Z. You write your Z plus. We have 2 here. You write your 2 plus. Now, we have a minus 1 here, but don't forget it was 2 of this minus 1. So that becomes 2 times minus 1. It therefore means that 88 will become Z plus times minus will give us minus. Or rather, let's do it this way. 2 plus, we have 2 here, plus times minus will give us minus. 2 times 1 will also give us 2. Now, what's 2 minus 2 is 0. So these 2 are eliminated. So we are left with 88 equals to Z. That simply tells us that the value of Z is how many? 88. Having said that, our final answer will now be represented as, if you come back here, we have our radon. A now has been gotten as 222. While your Z here has been gotten as 88. And that becomes your final answer. So this is the correct representation of radon. I know you guys might not be happy, but I have to end this live video now. A message just popped on my phone. I have to attend to something. I'm sorry, but I have to end this live video now. But before I end the live video, I'm going to give you a little time to write out what I have written on this book. I'm sorry, there's nothing I can do, but I just have to end it now. A message just popped up on my phone that requires my attention. Please. I'm so sorry. Musale Shekina, don't worry. I will try as much as possible to continue tomorrow. Okay? Please do where to like these videos. Please do where to like this video. Yeah, Jason, it's so simple. It's so simple. It's just the textbook that makes it so difficult. And that's why we're here. You're welcome, Jason. Don't worry, promise we'll be together tomorrow, okay? Just permit me for this. Permit me for today. I'm deeply sorry. All right, thank you so much. I love you all. And God willing, we'll meet again tomorrow to continue from where we stopped today, to take few questions and also expand our knowledge. Yeah, thank you, Eugene Adams. Thank you. All right, remain blessed then. I love you all.